Hello, my dear student, please rejoin the class. Was disconnected due to a network problem. Now join the class. I am connected now. Hello, dear students. Now join. We are discussing atom and molecule. Join the class, mentioning your role and section again. Disconnection occurs due to poor network connection. Due to poor network connection, I was disconnected. Now join the class as early as possible. Lubna is present. Thank you. Now join the class. We are discussing molecule, that is the determination of relative molecular mass. Relative molecular mass is the sum of relative atomic mass present in a molecule. Let us learn what is molecule. Molecule is the again short expression of an element or compound. Okay, element or compound. For example, molecule of sulfuric acid, H2SO4. Water molecule H2O. Okay, but atom is different. Atom means the smallest particle of an element. Molecule is the smallest particle of an element or substance. Okay, now here look at relative molecular mass. Relative molecular mass is determined from the relative atomic mass present in a molecule. For example, look at the molecule of sulfuric acid. Look at sulfuric acid consisting of one molecule of sulfuric acid consisting of 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. Okay. Now, calculation of molecular mass. I need to know the relative atomic mass of all elements present in a molecule. We know relative atomic mass of hydrogen is 1. Hydrogen is 1. Relative atomic mass of sulfur 32. Oxygen 16. Now molecular mass. How many atoms of hydrogen here? 1. Atomic mass, relative atomic mass of hydrogen is 1 times 2 plus Lajator. Then here you are again present. Thank you. Disconnection occurs due to poor network connection. Again I am reconnected. Now here molecular mass 1 into 2. How many atoms sulfur? 1. 32. How many atoms? 1. Then relative atomic mass of oxygen 16. How many atoms? 4. It will be 2 plus 32 plus 64. Now if you sum up, you will find 98. Okay, similarly carbonic acid, nitric acid. 1 atom of hydrogen, 1 atom of nitrogen, 3 atoms of oxygen. So 1 plus 14 plus 16 into 3 atoms of oxygen, 3 atoms of oxygen. So atomic mass of oxygen 16 times 3. Now you will have 1 plus 14 plus 48, and if you add, you find 63. Similarly, ammonia, that is nitrogen, atomic mass of nitrogen 14, hydrogen 1 into 3, okay, then you find 70. This is how we can easily calculate the relative molecular mass of any molecule, okay, and you have to calculate the molecular mass randomly. At any moment you have to calculate this. Instantly you have to calculate. Now let us go ahead. Then radioactive isotope. Isotope already have learned. Isotope means the atoms of the same element having different atomic masses but the same atomic mass, atomic number. Atomic number will be the same but atomic masses will be different. But radioactive isotope means the isotope which is very unstable and undergoes decay randomly. When it undergoes decay, then it produces radiation. And 3 types of radiations are usually found. They are alpha ray, beta ray, gamma ray. Okay, 3 types of ray are produced by radioactive isotope. Radioactive isotope means the isotope which produces radiation due to destruction of it. Radioactive isotope also various type of rays which are found from radioactive isotopes are also beneficial. This sort of radiation play various beneficial role nowadays, particularly in medical science, in agriculture. These rays are very important. Now medical science. In the medical science, various type of diseases are diagnosed with ray. Okay? With ray. That is radioactive isotope 99 technetium. 99 technetium. Technetium is an element, but this is radioactive. If it is injected in human body, it goes to target organ and produces radiation. Then a particular function can be performed by it. It produces gamma ray. And its lifetime is 6 hours. Lifetime is 6 hours. Lifetime 6 hours means it can function 6 hours. A single atom of technetium can continue functioning 6 hours at a stage. After 6 hours, it will be vanished. So that's why this is the lifetime. and produces gamma ray. Then another isotope, iodine 131. This is also used for the treatment of thyroid cancer. Thyroid cancer, iodine 131 isotope. Cobalt 60 used for the treatment of tumor. Then phosphorus 32. These are isotopes. 32 used for the treatment of leukemia. So how beneficial roles are played by this radioactive isotope, that is radiation produced by this isotope. These are the medical areas where we find the application of isotope. Now, in agriculture, there are a lot of uses of isotopes nowadays. That is, isotope is used for determine what type and what amount of nutrients exist in soil. As you know and we know, certain nutrients like nitrogen, zinc, magnesium, which are also nutrients for better growth of plants. But what amount of these nutrients are required for growing particular type of crops, it can be determined by the uses of isotope, radioactive isotope. Then harmful insect. When we grow various type of crops, even fruits, insects attack them. But we can kill insect by the radiation produced from various radioactive isotopes. So how many uses radioactive isotope has? So for the better growth of crops, radioactive isotopes are used. Again, radioactive isotope undergoes decay. That is, radioactive isotope breaks into two or more new nuclei, and whenever it transforms into two or more new nuclei with new atoms, huge amount of heat energy is produced. So radioactive undergoes nuclear reaction. During nuclear reaction, huge amount of heat, nuclear reaction. During nuclear reaction, huge amount of heat. This heat energy is used for the generation of electricity. In Bangladesh, there also a nuclear plant being set up. Nuclear plant is very effective, cheaper also, and huge amount of electricity can be generated by nuclear plant by side. Nuclear plant also risky. But very effective and very cheap also. Okay, how can we use nuclear plant to generate electricity? Nuclear plant, that is, nuclear reaction occurs, heat energy is produced. This heat is channeled into a vapor chamber. Heat into vapor chamber, where water vaporizes. This vapor Okay, rotate the turbines. Vapor rotates turbines. Rotate turbine. As a result, electricity generated. This is how nuclear plant function. In fact, nuclear plant produces heat. That heat again is used for vaporization water. Water vapor, okay, rotates the turbine. When turbine rotates, electricity generated. Okay, how many uses radioactive isotopes have? Okay, and very important uses and very beneficial roles are played by radioactive isotope. But radioactive plant, that is nuclear plant, I have talked about nuclear plant. Nuclear plant side by side produces huge risks. At any moment accident may occur, and it has very destructive power also. Bangladesh is a densely populated country, so setting up a nuclear plant in Bangladesh not easy. At any moment, if accident occurs, it may cause massacre to people, that is various type of animals, plants, which also may cause huge loss to the people, Bangladeshi people. That's why it is risky. You will have heard about the dropping of atomic bomb in Hiroshima and Nagasaki. Or Nagasaki and Hiroshima in Japan, there also atomic bombs were dropped. When atomic bombs are dropped, then bombs exploded during nuclear reaction. What a power, destructive power produced by it, you can't imagine. Within very few moments, the total area were damaged, massacred, including people, plants, animals, buildings, and everything else on that area, on the earth, in that area. So, nuclear reaction, nuclear plant or nuclear reaction, radioactive isotopes play a very beneficial role for us. Side by side, there are a lot of risks. So remember, this is the last topic of the chapter 3. Today I have discussed isotope, that is calculation of relative molecular mass. Then radioactive isotope means which produces radiation like alpha, beta and gamma. And radiation also play a vital role or beneficial role for us. Many beneficial roles are played by radiation in medical science, in agriculture, and even in many industry, or in generation of electricity. So chapter 3 also one of the important chapter. There are many information in the chapter. Chapter's title is atomic structure. We have found the definition of atom, element, symbol, formula, molecular formula, then atomic masses, atomic number, calculation of number of electron, number of proton, number of neutron also, and you can easily calculate. Then model related to atomic structure. Two models we have discussed, that is Rutherford's atomic model, Bohr's atomic model. Rutherford's atomic model is not so logical, but Rutherford atomic model is the base of atomic structure. Then Bohr's atomic model introduced later on. Bohr's atomic model is Bohr's atomic model also important. Those who are joining the class, please write your name, role and section. Bohr's atomic model also important. Bohr's atomic model is logical. Why Bohr's atomic model logical? I have discussed. Why Rutherford's atomic model unacceptable? I have discussed. What are the limitations with both models? I have discussed. Then relative atomic mass, calculation of relative atomic mass, calculation of relative molecular mass, and last of all, I have discussed the radioactive isotope, uses of radioactive isotopes. Where do we find the application of radioactive isotopes? Okay, these are what you should learn from the chapter. Oh, electronic configuration also. Electronic configuration. That is, electron, you can easily configure the electrons. You have also learned about the order of various orbitals. This is very, very important. Configuring electrons is very, very important. Already have learned. You can easily do that. And your midterm exam or assignment is very near. Next day assignment will start. Going to start. Next day will be given the assignment papers along with answer script. And already question already been made, easier question. I am sure you can easily answer. A syllabus already I have provided. You have already known about it. Chapter 1, 2 and 3. Chapter 3 you have finished. Again, next is start chapter 4. Chapter 4, periodic table. Now listen, during your midterm exam, your as usual class will be held. But on the day when you will come to take your assignment copy, classes will not be held. Your classes will not be held on the day of distribution. Except distribution day, your classes will be held on all other days. Remember. Okay, today's time is over. Next day again start from here. Thank you very much.